Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode ID 2785. Sort vowels in a string. This question has been asked in Google, Meta and Amazon recently. It is marked as medium. Will be based on sorting or string. Let's have a look at the problem statement. Here we are given a 0 index string S. Permute string to get a new string T such that all the consonants remain in their original places. More formally, if there is an index I, if I is a valid index and the value at I, character at I is a consonant, it means the character will remain at the same position in the final string. In short, consonants should maintain their existing order and vowels must be sorted in the non-decreasing order of their ASCII values. In short, vowels should be arranged in the ascending order. Vowels should be sorted and consonants should not be changed. This is nothing. Return the resulting string and these are the vowels. Can also appear in lowercase and uppercase letters. Consonants comprises all letters that are not vowels. Okay. So problem statement is pretty simple. It is just a bit confusing. What is given to us? We are given a string and that string is going to have uppercase and lowercase English alphabets. And now what we have to do is, this is the given part. What we have to do is, we have to sort every single vowel. Vowels are A, E, I, O, U and same in the uppercase letters. So these are our vowels. These we have to sort. And the other characters should maintain their order. So that's all we have to do and we have to return the final string. Okay, so let's try to see how we can do it. Here the string length will go till 10 to the power 5. If I try to have a look at this example, here let's see what are all the vowels. E is a vowel, E is a vowel, this is another vowel, O, this is also a vowel. So this E, E, O, E should be sorted. So A, E, I, O, U, A, E, I, O, U. Our vowels actually are A, E, I, O, U and capital A, E, I, capital O, capital U. We already know that the ASCII values of these small case English letters starts from 97 and these are previous, like capital letters have lower ASCII values, so definitely capital letters will be coming ahead of the lowercase English letters. So here we have E as a vowel and this is small e and capital O and small e. So if I have to sort it, it will be something like this: E, O, E, E. So this is in the sorted form, E, O, E, E. And we have to maintain the order. So these four indices where we pick the vowels, and apart from these four indices, all the other indices will have the same value. It will come as it is, it will come as it is, it will come as it is, these the same. So these four positions should have vowels in the increasing order, and to make them increasing order, this O should be coming here, E should be coming here, E, O, E, E. So this is the sorted form. So this is what we have to do. That's all about the problem statement. Given a string, in the string we just have to sort all the vowels and we have only 10 possibilities of the vowels: A, E, I, O, U in the smaller case and capital case. So this is our problem statement. So how we can do it? First of all, we are only concerned about the vowels, which are this one, this one, this one and this one. Apart from these, other characters will remain same. So if I convert this string into the character array, converting it to character array, and after converting it to the character array, I am going to capture what are all the vowels I'm going to encounter. Or how do I capture that? Let's say I'm maintaining them in a list. This E is a vowel, I'm taking it into a list. This small e is a vowel, taking in a list, taking in a list, taking in a list. So all of these vowels I have taken in a separate list, vowels list. And after that, I will iterate over the string again, iterating over the string again, and try to fill the next string. If it is a consonant, take them as it is. If it is a vowel, do not take it from the initial string. Instead, all those vowels we have captured, we are going to first sort them. After sorting, it will be something like this: A, E, I, O, U, and small e, small e. This is sorted form. Vowels we captured separately, and then we made them sorted. So this is one step we did. And after that, when I'm doing the iteration, when it is a vowel, discard it, instead pick from here, AE. This is a vowel, discard it, pick from here, O. It is a T, as it is, C as it is, O. It's a vowel, discard it, pick this one. That is E. D, take as it is. E is a vowel, take from the vowel sorted list. So this is how we can form our final string. And this character array we can convert it to the final result, or directly take it as a string builder, mutable string. Okay, so this approach we can do, and what we did is just did the simulation, whatever is asked, we just did the same. So first of all, I did one iteration over the string, and that one iteration is around order of n time. And after that iteration, along that iteration, I just converted it to character array, and when I'm doing the iteration, I'm going to capture every single vowel in a list. So in the list, I have captured every single vowel, and then I'm sorting that list. So that list, I just sorted it. Now, what is the time complexity to sort a list, sort a data structure? Let's say in the worst case, every single letter is a vowel. So the sorting will take around order of n log n time. After that, I'm just doing one more iteration and capturing the vowels from the sorted list. So that is another one order of n time operation. In total, we have order of n log n time operation. What about the space? See, space can be anything. Space, whatever the space this sorting operation is taking, that is going to be our space. So space, let's say we have used merge sort, and that is going to take log n time complexity. So this is the time and space complexity of our approach, n log n, but we can still optimize it further. How we can optimize it? Because in this vowels list, we are going to have limited options. Let's have a detailed look on the optimized approach. We are trying to optimize it further. This is the string, and as we have to capture all the vowels, we know we have only limited options of vowels: A, E, I, O, U, and capital A, capital E, capital I, capital O, and capital U. So these are the set where we have every single vowel, and if any element is coming from that set, we have to make them sorted. So instead, we can do something like capturing the frequency. Capture frequency of every single vowel. In that case, we have only 10 options. Even if we are going to take 128 size array to include every single ASCII element, if we initialize integer array of 128 size, by default it is initialized with 0, and whenever I am going to encounter a vowel, I will increase the frequency of that vowel. if I try to iterate over this, this is E, this is L, first letter is L is a consonant, we just ignore it. Second one is E, just capture the frequency of E is coming one time, and then this is small e is coming one time, T, ignore it, C, ignore it, O is coming one time, D, ignore it, E is coming one time, so E is coming two times. So this is going to be the custom hash table for our approach. Custom hash table means we are just making this array as a custom as a hash table. We are not maintaining some kind of fancy data structure like hash map. We are just doing it by this single array of integers. So this is how we can capture the frequency of every single vowel. After that, what I can do is, when I'm forming the new string, if it is a consonant, just take it as it is. If it is a vowel, just try to pick items from this list, and in this list those indices are representing the ASCII value of the character, and those indices are already sorted because it is going from 0 to 127, and whatever is the ASCII value of E, that index we are able to find the value. So we are just going to capture the first non-zero value and pick items from this entry one by one until it is 0. So it is a vowel, so we are going to pick this E first, and it will be reduced to 0, picking E, and then it is E again, it is a vowel again. If it is a vowel, then E is already done. Now we'll come to O is 1, we have used one O, I will use one O, and then T is a consonant as it is, C as it is, O is a vowel. I'm going to capture this E now. This E, 1 is used, 1 is remaining, using E, and then D as it is, and if it is a vowel, use this E as well. And now this is my final string where we have all the vowels sorted. So here, what is the difference between this approach and the previous approach? In the previous approach, we just directly used a sorting function, which is going to make it more complex in terms of time, making it n log n time. But instead, if we are maintaining a custom hash table, that custom hash table is going to be of a fixed size array, and that fixed size array means it's a constant time operation. So we are doing the iteration, filling our custom hash table, that is order of n time, and the hash table is also of this size. There is no need to be making it sort again, and then iterated over the same string again, that is also order of n time operation. But when I'm iterating over the string again, I will be iterating and picking items from the custom hash table. So here the concept that we used is custom hash table, and here we did not sort anything, and the time complexity is order of n time. And what about the space complexity? Space complexity is constant. This is time and this is space. So that's how we can optimize it and do it in a linear time. So I hope you understood the approach. Now let's have a look on the code. So here, as a part of code, what we are doing is, step 1 is, first of all, we have to maintain a set of vowels so that we can directly check whether a character is a vowel or consonant. So for that, I am maintaining a set, and after that we'll just capture the frequency of all the vowels. If the character in the string is a vowel, then capture the frequency, because we have to pick those character later on when we are building the string. So now it is a time to rebuild the string, taking a string builder and iterating over the characters. If it is a vowel, then I will do something, otherwise I will use the character as it is. If it is a vowel, then I will pick the first vowel from our frequency, from our count, from our character, from our count frequency of vowels, this data structure. Got it? So vowels contain C. If this vowel set contains the current character, it means that current character is a vowel, and now I need to pick vowel from our sorted data structure. because we are sorting all the vowels. So now from this count array, whatever index is going to have a value greater than 0, whatever value is non-zero. So as far as we are getting 0, I'm going to increment it. Otherwise, when I'm coming here, when I'm coming at line number 27, it means that this pointer is having a value which is non-zero. So I will use the same character in the string and I will decrement the count. So this is kind of a trick that I have used, and we are just using our custom table in this case, and forming our new string. That's all about the code. This is not a very difficult to understand. It's like that we can utilize the time not just by doing the sorting, we can save it by making a counting sort. So we are just using the counting sort in this case, so that our time complexity remains in order of n. That's all we have to do. Okay, I hope you understood the code, and still if you have any doubt you can comment down below. Thanks for watching guys. Bye bye.